Brush DC motor control group 5. We are a group of 2 people, and our project was originally based for controlling the motor speed, because we were planning to put a fan on, and then that fan would regulate the temperature. We were going to get the feedback as our feedback temperature. We're going to any type of a temperature sensor, like a LM35 or thermistor, any of those would have been fine. Yeah, so this is a simple schematic that we have created. So, simple H-bridge, motor control, and then our our temperature sensors, either thermistor or LM35. So we couldn't get our hands on a thermistor, and because the lab were closed, and also all the electrical shops were out of our reach because of the coronavirus that's going on these days. And then also the LM35, which is on the interface board that was provided by the school. The interface board, we couldn't get it to work because the problem is that we need a power supply, a 12-volt power supply, and not just any 12-volt power supply. We need a higher amps one because we were also planning to control the motor with it. So at our house we couldn't find anything that would be able to do that. But anyway, we still managed to finish our project based on our code and our debugging tools. So I'm gonna just try to briefly go over how we're doing everything, what type of peripherals we're using. So we're using basically 4 peripherals: PWM signals that we generate to control the H-bridge in order to control the motor at 100 Hertz, and then also we're using ADC, analog to digital converter, and we're using a 12-bit conversion here. Also, we're using interrupts. We're using interrupts as a external interrupt, as a button interrupt to start and stop, emergency stop the system, so it would just kill the switch. So that was like a killer switch and a start switch. And then also we're using the UART as our basic debugging and display our code, right? Yeah, without further ado, I'll just try to run our code, debug it, see what happens. Debug. So there we go. Our memory map has initialization completed, and I'm gonna use a real-term as our serial capture program. There are other programs as well. You can use Terraterm. I'm using real-term. The baud rate we've set at 115200, port 9. I'm gonna clear it. I'm gonna refresh, reset the board, the controller, and then I'm gonna press the start button. So as you can see, our ADC temperature values are floating, right? This is because it's not connected to anything. I've tried to put it at ground or some type of temperature, but as you can see, our duty cycle is trying to adjust to that, and then this is the percentage, so 0 to 100. Anyway, and then I'm gonna use this switch again to kill it. So there we go, emergency stop, interrupted, duty cycle set to 0. It's gonna stop the fan. So right here, I'm gonna try to go over our PID loop briefly. So this is a main function that generates a new PID, feedback loop. So it takes 2 variables, current temperature and then current duty cycle. What it does is it calculates the error, and using the error and the previous error, it develops a new PID, a variable that you can use to generate a new duty cycle, right? And here, as you can see, we are changing the duty cycle based on this function, and then it returns a value that generates a new duty cycle. So this is just briefly trying to explain how our system works. Yes. That concludes our demo. We will try to further explain our code in the report.